What's up, everybody, and welcome to OpenStax Calculus 2.2, the limit of a function. We're going to be going through a number of questions to explain the concept of what a limit means and to evaluate a lot of these limit-based questions. So without further ado, let's do it. So in this question, it says we're going to use a table to figure out what the limit is as x approaches 0 of this function. Now, the purpose of a limit, which I think gets glossed over a lot of times, is we're trying to answer a question that would normally be unanswerable. So what we have here, right, for example, sine of 2x over x, if you actually just said, hey, what is the value at 0? What you would see is you would say sine of 2 times 0, which is, of course, 0 over 0. Sine of 0 is 0 over 0. This is an indeterminate value, okay? So this is not answerable. But what a limit allows us to do is instead of asking what is the value at 0, it's saying, well, maybe it's indeterminate right there. Maybe a value doesn't exist, but is it approaching a value? Is this function converging towards some sort of value near 0? Hey, there might be a hole there. It might not actually exist, but again, there is a potential value that it is approaching, and that's what a limit aims to answer. So now if we look at the graph of sine of 2x over x, you can see that from the graph, it's not as though there's nothing here. It is approaching a single value, right? From both sides, left and right. It seems to be approaching this value of 2. But then when we get right to that point, right when x is equal to 0, you notice it says undefined. So the limit is going to answer the question, not what is exactly at that point. That's undefined. But what it's answering is what is the value, what's the function value that we're approaching from the left and right-hand side. So when we calculate a limit, what we're doing is we're slowly getting closer and closer to 0. So you can see that these values from the negative side, from the left side, we're slowly approaching a little bit more closely to 0. And then we're doing the same thing from the right side, again, starting at 0.1, then getting closer and closer to 0. And we're just looking to see the trend. What are the values approaching? So here's our table, right? What I'm doing is I'm plugging in these values, getting closer and closer to 0.00008, basically 0, right? So we're going 0.1, 0.01, 0.001, etc. Now you can see the progression. Again, this is from the right-hand side. We're getting closer and closer to 2. This actually says 2, but that's because they rounded. It's still going to be like 1.9999999, not exactly 2, but it's clearly going towards 2. And we have the same progression from the left-hand side, right? And here are all the points that it's showing right there that we've put out here, right? So negative 0.1, 1.98, 1.99, 1.99999, and then we're getting dangerously close to 2. So this table, this methodology shows us that the limit as x approaches 0, not when x is equal to 0, right? But the limit as x approaches 0 of this function is 2. And just again, so you can see, if we actually put in 0, we get that undefined value. That doesn't help, but the limit gets us to the point where you can say, oh, fine, the value doesn't exist, but it's approaching that value of 2. So anyways, 2 is the final answer. That's how you do it. Done. For this question, we are given a graph and we're meant to evaluate these different limit values that have been provided down below and see if they're actually true, okay? So we're gonna look through these questions. I'm gonna explain what it's asking in each. Now, this first one says, this is f of x, right? This entire function, everything drawn here. This first one says, what is the limit as x approaches negative 2? And they're saying that it's equal to 3. But then you might say, well, what's this little plus sign? What that means is we're saying, the limit as x approaches negative 2 from the right. If there was a minus sign, it would be from the left. So we're saying from the right, and they basically are asserting that that limit is equal to 3. So we're going to check. Let's look at this function. And obviously, to the right of negative 2, here we have negative 2 right here, right? So to the right of that is going to be all of this. But what we want, when they say to the right, we want really close to negative 2, right? So we're talking like in this zone. Let's see, where is it approaching? What is it approaching from the right-hand side? Now, right at negative 2, there's a break. And the actual function value at negative 2 looks to be 3. But that's not what they're asking. They're asking, what is this approaching? What value is it approaching from the right-hand side? And it looks to be approaching 7. Now, I can't tell if there's an asymptote here and there's an arrow going up forever and ever. What this appears to be is an open circle right here, meaning that we're kind of stopping right there at 7, and that's what it's approaching, and then it's picking up at 3 when we go past negative 2, right, or right at negative 2. But so when we're looking back at this, is the function value approaching 3 from the right? No, it's approaching 7. So this one would be false. And the reason why is because it actually should equal 7. Now let's look at this one. This is saying the limit as x approaches 6 is equal to 5. Now, when there's no plus, when there's no minus, we're not saying from the left side or from the right side in isolation. We're saying from both sides. And for this limit to actually exist, we need it to be approaching the same value from the left and the right. So let's take a look at this. So if we look at it from the right-hand side, that's from this side, right? What is it approaching? Oh, look at that. It is going to 5. I believe it is approaching 5 from the right-hand side. So we can write this as the limit as x approaches 6 from the right-hand side of f of x, that certainly does equal 5, right? What about from the left-handed side? Okay, so we'd say, what is the limit as x approaches 6 from the left? So we're going to use a different color here. I'm going to use this pink color. So where is it approaching? It's not approaching 5. It's approaching 2, right? It's getting closer and closer to 2. Here it's maybe 2.5, 2.2, 2.1, whatever. So it's approaching 2. So that means the limit as x approaches 6 from the left of f of x is equal to 2. So the question is the overall limit, the two-sided limit, equal to 5? Well, in order for that to be the case, this and this must both equal 5. Well, when they're different, what that means is the two-sided limit does not exist. The limit would only exist if both of them were approaching the same value from the left and the right-hand side. So this is also false. It does not equal 5. Now, just to give you a contrary example where there would be a limit, if we look, for example, as the limit as x approaches -8, okay? And I'm talking about a two-sided limit. In this one, from the left, it looks like it's approaching -6. From the right, it looks like it's also approaching -6, which means that the limit, if we were asking this, the limit as x approaches -8, two-sided limit I'm talking, is of f of x would be equal to -6. Now you might be saying, wait a minute, the actual function value is not at -6, so this has to be wrong. Incorrect. We don't actually care about where the function value is. All I care about is, are we approaching the same value from the left and the right? The fact that the limit is different than the function value has no bearing on the existence of the limit. So anyways, back to 49, the answer is false because the limit actually does not exist. It is not 5. That's how you do it. Done. For this one, we're answering these two questions. We're trying to find the limits, and this is our function. So this is, again, because of that minus, it's saying the limit as x approaches 0 from the left of f of x. So let's take a look. So here is 0, right? Right down on the y-axis. And if we're talking about from the left, we're talking about from this side, right? What is it approaching from the left-hand side? It looks like it's approaching 1. It never hits 1, but that's okay. It's not asking what's the function value at 0. It's saying what is it approaching from the left, and it is approaching 1. Now, if they were asking what is the limit from the right-hand side, okay, as x approaches 0, that would be -4, right? Because it's coming down and it's approaching, it's getting closer and closer to -4. It also equals -4 at 0, but that's not the question, right? It's saying if we said x approaches 0 from the right, this would be -4. Now, the next question we're answering is, what about the two-sided limit? What does that equal? Well, again, to get the two-sided limit, first of all, I need to know that the left-handed limit and the right-handed limit are the same, because then if they're the same, that exact value would be the answer for the two-sided limit, but they're different. On this side, it's approaching 1. On this side, it's approaching -4. When they're approaching different values, that means we don't have a consensus for the two-sided limit, meaning the two-sided limit does not exist. That's how you do it. Done. So for this question, we're trying to graph a function with the given properties. And these can be pretty difficult for students. So I'm going to show you my process, okay? The first thing I'm going to look for is I'm going to look for concrete values. So I see right here, it's saying f of 0 is equal to 0. That's a coordinate. That coordinate is 0, 0. So I'm going to plot that right off the bat. We're going to see if there's anything else like that. That's the only coordinate, so I'm going to put that in right there. Now, out here, as x approaches infinity, f of x goes to 2. As x approaches -infinity, f of x goes to 2. That's kind of my end behavior. That also constitutes a horizontal asymptote, because as we go out to the left and the right, it looks like it's approaching this function value of 2. What I'm going to do is I'm going to draw in a horizontal asymptote just to show that, yes, we're going to be approaching 2 from the left and the right. But this isn't actually technically part of the graph of the function. Okay, now let's look at this. It says as x approaches -2, again, that's a two-sided limit because there's no plus, there's no minus. So from both sides, we're going towards -infinity. What does this look like? That means as we get to -2, which is right here, right? We're going down to -infinity. From the other side, we're going down to -infinity. Now, there could actually be a value at -2 of the function, but I'm going to assume since they didn't say, hey, when x is -2, this is what f of x is, I'm going to assume there's a vertical asymptote there. Now, let's finish this off by applying the end behavior that we talked about here and here. So again, this is saying as x goes to infinity, as x goes to the right, we're approaching a function value of 2. So since we're already below it right here, I'm just going to draw it in like this. Now, again, it doesn't say that it can't cross. You could theoretically have it cross and then have it approach from the top. But I'm just keeping it simple here. This is one way to do it. So we're approaching 2 as we go to the right. And then this one is as we go to the left. We're also approaching 2. So I'm going to have it come up and kind of come under here and say it's getting closer and closer to the value of 2. It's never going to hit 2 necessarily in my rendering, in my drawing, because that's all this says. As x goes to -infinity, we're going towards 2, not actually equaling 2. So now we have an accurate drawing of the graph. Again, this is one way to do it. There could theoretically be other ways with other variations, but this is one way to do it. Hope that makes sense. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more videos from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and we'll see you in the next video. Take it easy.